Hi Inez. This week I'm going to be trying a completely new editing style, talking about math, Photoshop, and a lot of other things. Please stand by, this might take a moment to load, but it's going to be cool, I guarantee. See, look, I can do the intro. I can do the intro without actually doing any editing. Look at that, aren't I cool? X out of that. So this is a function that I sort of invented, sort of made, not really sure. Anyway, I don't know if I invented it or not, but it's cool. This is just simply the graph of sine x over sine y equals z. I'll move it around somewhat so you can get your bearings, and I'll likely have a link to this in the doobly-doo description. But this is, it's a relatively complicated graph. It repeats on every unit square of pi. So, 1 pi, 2 pi, all those things. You can see the square shapes that it makes. But this has another weird, interesting, and very important property. And I want to show that to you because that's why I'm really excited about it. Also, I don't know if you know this, but GeoGebra now does 3D graphing, which is amazing. It also does like 3D solids and things like that. So first one, I'm going to make a plane of y equals 7. And as you can see, there's the bounding box in this. It only renders a small section. And between the plane y equals 7 and the bounding box, there's only this small section, which forms a sinusoid. Now, I don't know if this is a sine or a cosine, but it doesn't really matter. They're both sinusoids. They're both the same. And if I rotate this, I can then move this plane sideways. Y equals 6.8, maybe? 6.8. And the sine curve that's intersecting with the blue gets bigger. 6.6, perhaps. And this is as it's approaching 2 pi from above. You can see that it's getting larger, which means that with this simple form, I can generate, with this simple cross-section, I can generate any sine function shape of any amplitude and the frequency. You just kind of change the properties over here in this section. So that's one of the cool things it does. The next cool thing it does is shown in the opposite axis. You get a plane along x equals -7. 7 would also work. -7 just happens to be how I put it. Or x equals any number. And this is making a graph of a cosecant shape, which is, again, surprising and really cool. Like, what the heck? So the -6, also cosecant, just in a different spot. This one is where Mom's spatial reasoning kind of flew out the window. So I'm going to put this back to -7 because she's going to prefer that. But you see what I mean, I hope. This is a cosecant graph, and therefore also a secant graph. I know. So that's the next cool thing. And then the third cool thing is a plane that is not along the x or y axes. And this one I'm going to have to zoom in for, which you just do with the mouse wheel in that direction. Oh, by the way, GeoGebra spins. For days it spins. I'm going to slowly rotate this around, trying to give you all the best possible angles with which you should be able to determine that, as a matter of fact, the intersection along a plane that is slanted is, in fact, a tangent. It is a series of tangent lines. It is the graph of the tangent function, if I can even English. So all this is generated just from sine x over sine y, and taking cross-sections of it. And obviously all the math checks out here. It's just really cool to find this curve shape that contains all of these things. And I'm confident that if I have like 2x plus y equals 2, then I'll get a different form. I'll get some Franken function that's not a tangent and not a cosine or a sine or a secant or anything. So excited to continue exploring those. I don't know if anyone has ever done this before. I really haven't a clue. I'm working on looking it up, but you can't just search it because Google sucks. Anyway, on to part 2, as I have been hinting to, and I sadly will not complete the showing of. This is a big printer. Please reference like markers and a whiteboard and a printer. It's huge. Like, I could put my arm in this bit. I can't point to the screen. In this bit and stick it out that bit, and I have just like my wrist left. It's huge. I can't fit my hand in there. I'd probably get in a lot of trouble if I did. That thing is being used by this person, Miss Edmondson, to print my thing. A lot of other things as well. This is one of my projects. This is Miss Edmondson. This is a project. This is part of it. These are some of the people there, because we had to cut foam boards, which you will see in a moment. Oh my goodness. Look at that. Massive Mac monitor and standard Mac keyboard for scale. This is the cutout of my other piece of art. I assume that the piece of art that I showed you on the computer screen has in fact been cut out already, but I don't know. I'm just kind of guessing. Anyway, last thing for today. I don't know if I've told you. I have to assume I have. But for everyone else, this is a small cube of stone. This small cube of stone is going to become a D6 die, which also means that I have a bunch of other pieces of stone, little tiles, which were cut from the scrap that I couldn't use. All of this scrap is provided free by a countertop place in town. I have a few other chunks of stone in the backyard next to the shed and the not shed. So yeah, those will be introduced as I continue working. My plan is to get jigs 3D printed, because I have a stone saw, obviously. And then I'm going to polish them up, laser engrave them. I have the gold leaf, and I'm super excited because, yeah! Anyway, tell me what you think about the new format. Tell me what you think about the photographs and not photographs. Tell me what you think about all the things, because this was actually really easy to make. I'm like done as soon as I hit done. And if it's done lagging, come on. I'm really sorry about the frame rate, everyone. I'm going to do this real slow. I hope you have a fantastic week. Slow hand wave. Whoa, that was cool. Anyway, adios. Rock on.